हेलो बच्चों, इस एपीसोड विच तुसी प्रॉपर्टीज ऑफ एडिशन एंड सबट्रैक्शन ऑफ कंपलैक्स नंबर्स बारे पढ़ोगे। तुसी इन्हां बारे तां जानदे ही होवोगे। इमेजिनरी नंबर्स, कॉम्पलैक्स नंबर्स, इक्वालिटी ऑफ कॉम्पलैक्स नंबर्स, एडिशन ऑफ कॉम्पलैक्स नंबर्स अते सबट्रैक्शन ऑफ कॉम्पलैक्स नंबर्स। आओ हुण शुरू करिए। Let us first recall the addition and subtraction of two complex numbers. The sum of two complex numbers. If Z1 is a complex number whose real part is A1 and imaginary part is B1. Also, Z2 is a complex number with real part A2 and imaginary part B2, where Z1, Z2 belong to the set of complex numbers. Then the sum of these two complex numbers, that is Z1 plus Z2, is equal to the sum of their real parts plus iota into sum of the imaginary parts. That is, the sum of two complex numbers Z1 equal to A1 plus iota B1 and Z2 equal to A2 plus iota B2 is defined as the complex number A1 plus A2 plus iota into B1 plus B2. The subtraction of a complex number Z2 equal to A2 plus iota B2 from a complex number Z1 equal to A1 plus iota B1 is defined as the complex number A1 minus A2 plus iota into B1 minus B2. Now let us discuss the properties of addition of complex numbers. The first property states that the addition of complex numbers is commutative, which means that for any two complex numbers Z1 and Z2, we have Z1 plus Z2 is equal to Z2 plus Z1. Let us prove the above property. Let Z1 equal to A1 plus iota B1 and Z2 equal to A2 plus iota B2, where A1, A2 and B1, B2 are real numbers. Then, by the definition of addition, Z1 plus Z2 is equal to A1 plus A2 plus iota into B1 plus B2. Since we know that addition of real numbers is commutative, therefore we get Z1 plus Z2 is equal to A2 plus A1 plus iota into B2 plus B1. Again, by definition of addition, we get Z1 plus Z2 is equal to Z2 plus Z1. Thus, Z1 plus Z2 is equal to Z2 plus z1 for all z1, z2 belonging to the set of complex numbers. Hence, we can say that addition of complex numbers is commutative. Second property states that addition of complex numbers is associative, which means that for any three complex numbers z1, z2 and z3, we have z1 plus z2 whole added to z3 is equal to z1 whole added to z2 plus z3, where z1, z2 and z3 belong to the set of complex numbers. Let us prove this property. Let z1 equal to a1 plus iota b1, z2 equal to a2 plus iota b2 and z3 equal to a3 plus iota b3, where a1, a2, a3 and b1, b2, b3 are real numbers. Then, by the definition of addition, z1 plus z2 plus z3 is equal to a1 plus a2 plus iota into b1 plus b2 plus a3 plus iota b3. Again, by the definition of addition, it will be equal to a1 plus a2 plus a3 plus iota into b1 plus b2 plus b3. Since we know that addition of real numbers is associative, therefore we get a1 plus a2 plus a3 plus iota into b1 plus b2 plus b3. By the definition of addition, we get a1 plus iota b1 plus a2 plus a3 plus iota into b2 plus b3. Again, by the definition of addition, we get z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. Thus, z1 plus z2 whole added to z3 is equal to z1 whole added to z2 plus z3 for all z1, z2 and z3 belonging to the set of complex numbers. Hence, we can say that addition of complex numbers is associative. The third property is the existence of additive identity. It states that the complex number 0 written as 0 plus iota 0 is the identity element for addition. That is, z plus 0 is equal to z, which is equal to 0 plus z for all z belonging to the set of complex numbers. Let us prove this property. Let z is equal to a plus iota b be any arbitrary complex number. Then z plus 0 is equal to a plus iota b plus 0 plus iota 0, which is equal to a plus 0 plus iota into b plus 0, which is further equal to a plus iota b, which is equal to z, and 0 plus z is equal to 0 plus iota 0 plus a plus iota b, which is equal to 0 plus a plus iota into 0 plus b, which is further equal to a plus iota b, which is equal to z. Thus, z plus 0 is equal to z, which is equal to 0 plus z for all z belonging to the set of complex numbers. Hence, the complex number 0 equal to 0 plus iota 0 is the identity element for addition. The fourth property is the existence of additive inverse. It states that for any complex number z equal to a plus iota b, there exists minus z, which is equal to minus a plus iota into minus b, such that z plus minus z is equal to 0, which is equal to minus z plus z for all z belonging to the set of complex numbers. Let us prove this property. Let z is equal to a plus iota b be any arbitrary complex number. Then minus z is equal to minus a plus iota into minus b is also a complex number, such that z plus minus z is equal to a plus iota b plus minus a plus iota into minus b, which is equal to a plus minus a plus iota into b plus minus b, which is further equal to 0 plus iota 0, which is equal to 0, and minus z plus z is equal to minus a plus iota into minus b plus a plus iota b, which is equal to minus a plus iota into minus b plus b, which is further equal to 0 plus iota 0, which is equal to 0. Thus, for each complex number z equal to a plus iota b, there exists a complex number minus z, which is equal to minus a plus iota into minus b, such that z plus minus z is equal to 0, which is equal to minus z plus z. Thus, the complex number minus z is called the additive inverse of z.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ properties of addition
ਐਂਡ ਸਬਟ੍ਰੈਕਸ਼ਨ ਆਫ ਕੰਪਲੈਕਸ ਨੰਬਰਸ ਬਾਰੇ ਪੜ੍ਹਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ। Let us see an example. Express 3 whole multiplied by 7 plus 7 into iota plus iota whole multiplied by 7 plus 7 into iota in the form a plus iota b. Power 3 whole multiplied by 7 plus 7 into iota plus iota whole multiplied by 7 plus 7 into iota ਨੂੰ a plus iota b ਦੇ ਰੂਪ ਵਿੱਚ ਐਕਸਪ੍ਰੈਸ ਕਰੋ। Now let us see its solution. Here in the above example we have 3 whole multiplied by 7 plus 7 into iota plus iota whole multiplied by 7 plus 7 into iota. We have to express it in the form a plus iota b. On solving it, it is equal to 21 plus 21 into iota plus 7 into iota plus 7 into iota square. Because we know that iota square is equal to -1. So it is further equal to 21 plus 21 into iota plus 7 into iota plus 7 into -1. On solving it further, it is equal to 21 minus 7 plus iota whole multiplied by 21 plus 7, which is equal to 14 plus 28 into iota. So here, on solving the given expression, we get a complex number whose real part is 14 and imaginary part is 28. Therefore, the given expression 3 whole multiplied by 7 plus 7 into iota plus iota whole multiplied by 7 plus 7 into iota when expressed in the form a plus iota b is equal to 14 plus 28 into iota. Which is the required solution. Let us see another example. Express 1 upon 3 plus 7 upon 3 into iota plus 4 plus 1 upon 3 into iota minus 4 upon 3 plus iota in the form a plus iota b. Powers 1 upon 3 plus 7 upon 3 into iota plus 4 plus 1 upon 3 into iota minus 4 upon 3 plus iota ਨੂੰ a plus iota b ਦੇ ਰੂਪ ਵਿੱਚ ਦਰਸਾਓ। Now let us see its solution. Here in the above example we have one upon 3 plus 7 upon 3 into iota plus 4 plus 1 upon 3 into iota minus 4 upon 3 plus iota we have to express it in the form a plus iota b. First of all, combining the real and imaginary parts and then solving it. This is equal to 1 upon 3 plus 4 plus iota whole multiplied by 7 upon 3 plus 1 upon 3 minus 4 upon 3 plus iota this is further equal to 1 plus 12 whole divided by 3 plus iota whole multiplied by 7 plus 1 whole divided by 3 minus 4 upon 3 plus iota which is equal to 13 upon 3 plus 8 upon 3 into iota minus 4 upon 3 plus iota. Again, on combining the real and imaginary parts and then solving it, we get this is further equal to 13 upon 3 minus 4 upon 3 plus iota whole multiplied by 8 upon 3 minus 1 which is equal to 13 upon 3 plus 4 upon 3 plus iota whole multiplied by 8 minus 3 whole divided by 3. This is equal to 17 upon 3 plus 5 upon 3 into iota. So here, on solving the given expression, we get a complex number whose real part is 17 upon 3 and imaginary part is 5 upon 3. Therefore, the given expression 1 upon 3 plus 7 upon 3 into iota plus 4 plus 1 upon 3 into iota minus 4 upon 3 plus iota when expressed in the form a plus iota b is equal to 17 upon 3 plus 5 upon 3 into iota which is the required solution. ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਪ੍ਰੋਪਰਟੀਜ਼ ਆਫ ਐਡੀਸ਼ਨ ਐਂਡ ਸਬਟ੍ਰੈਕਸ਼ਨ ਆਫ ਕੰਪਲੈਕਸ ਨੰਬਰਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Let us see another example. For the complex numbers z1 whose real part is 2 and imaginary part is 3, that is the complex number z1 which is equal to 2 plus 3 into iota, and another complex number z2 whose real part is 3 and imaginary part is minus 2, that is the complex number z2 is equal to 3 minus 2 into iota. Prove that addition is commutative. ਭਾਵ ਦਿੱਤੇ ਗਏ complex numbers z1 is equal to 2 plus 3 into iota ਅਤੇ z2 is equal to 3 minus 2 into iota सिद्ध करो कि एडिशन कम्यूटेटिव है। Now let us see its solution. Here in the given example we have complex number z1 which is equal to 2 plus 3 into iota, that is z1 is a complex number whose real part is 2 and imaginary part is 3, and another complex number z2 which is equal to 3 minus 2 into iota, that is z2 is a complex number whose real part is 3 and imaginary part is minus 2. We have to prove that addition is commutative. So here we have to show that z1 plus z2 is equal to z2 plus z1, where z1 and z2 belong to the set of complex numbers. Now, first of all, z1 plus z2 which is equal to 2 plus 3 into iota plus 3 minus 2 into iota. Combining the real and imaginary parts and then solving it, we get z1 plus z2 is equal to 2 plus 3 plus iota whole multiplied by 3 minus 2 which is equal to 5 plus iota. Let this be equation number 1. Also, we have z2 plus z1 which is equal to 3 minus 2 into iota plus 2 plus 3 into iota. Now, on combining the real and imaginary parts and then solving, we get z2 plus z1 is equal to 3 plus 2 plus iota whole multiplied by minus 2 plus 3 which is equal to 5 plus iota. Let this be equation number 2. So, from equation number 1 and equation number 2, we get Z1 plus Z2 is equal to Z2 plus Z1 . Hence, addition is commutative . So the required result is proved. Let us see another example. For the complex numbers Z1 whose real part is 2 and imaginary part is 3, that is complex number Z1 equal to 2 plus 3 into iota. Another complex number Z2 whose real part is 3 and imaginary part is minus 2, that is complex number Z2 equal to 3 minus 2 into iota. And third complex number Z3 whose real part is 5 and imaginary part is minus 4, that is complex number Z3 equal to 5 minus 4 into iota. Prove that addition is associative. पाव दिए गए कॉम्प्लेक्स नंबर्स Z1 इक्वल टू 2 प्लस 3 आइटा, Z2 इक्वल टू 3 माइनस 2 आइटा एंड Z3 इक्वल टू 5 माइनस 4 आइटा सिद्ध करो कि एडिशन एसोसिएटिव है। Now we will see its solution. Here in the given example we have complex number Z1 is equal to 2 plus 3 iota, complex number Z2 is equal to 3 minus 2 iota and complex number Z3 is equal to 5 minus 4 iota. We have to prove that addition of these three complex numbers is associative. That is, here we have to show that Z1 plus Z2 whole added to Z3 is equal to Z1 whole added to Z2 plus Z3, where Z1, Z2 and Z3 belongs to the set of complex numbers. Now Z1 plus Z2 whole added to Z3 is equal to 2 plus 3 into iota plus 3 minus 2 into iota whole added to 5 minus 4 into iota. Combining the real and imaginary parts and then solving it further, it is equal to 2 plus 3 plus iota whole multiplied by 3 minus 2 whole added to 5 minus 4 into iota. This is equal to 5 plus iota plus 5 minus 4 into iota. Again, combining the real and imaginary parts and then solving, it is equal to 5 plus 5 plus iota whole multiplied by 1 minus 4, which is equal to 10 minus 3 into iota. Let this be equation number 1. Also, Z1 whole added to Z2 plus Z3 is equal to 2 plus 3 into iota whole added to 3 minus 2 into iota plus 5 minus 4 into iota. On combining the real and imaginary parts and then solving, it is further equal to 2 plus 3 into iota whole added to 3 plus 5 plus iota whole multiplied by minus 2 minus 4. This is further equal to 2 plus 3 into iota plus 8 minus 6 into iota. Again, on combining the real and imaginary parts and further solving, it is equal to 2 plus 8 plus iota whole multiplied by 3 minus 6, which is equal to 10 minus 3 into iota. Let this be equation number 2. So, from equation number 1 and equation number 2, we get Z1 plus Z2 whole added to Z3 is equal to Z1 whole added to Z2 plus Z3. Therefore, addition is associative. So the required result has been proved.
In this episode, you have learnt about the following: sum or difference of two or more complex numbers is equal to sum or difference of their corresponding real parts plus iota into sum or difference of their corresponding imaginary parts. Properties of addition of complex numbers. First property, addition of complex numbers is commutative. It states that for any two complex numbers Z1 and Z2, we have Z1 plus Z2 is equal to Z2 plus Z1, where Z1 and Z2 belong to the set of complex numbers. Second property, addition is associative. It states that for any three complex numbers Z1, Z2 and Z3, we have
Z1 plus Z2 whole added to Z3 is equal to Z1 whole added to Z2 plus Z3,
where Z1, Z2 and Z3 belong to the set of complex numbers. Third property, existence of additive identity. It states that the complex number 0 equal to 0 plus iota 0 is the identity element for addition. That is, z plus 0 is equal to z, which is equal to 0 plus z for all z belonging to the set of complex numbers. Fourth property, existence of additive inverse. It states that for any complex number z equal to a plus iota b, there exists minus z, which is equal to minus a plus iota into minus b, such that z plus minus z is equal to 0, which is equal to minus z plus z for all z belonging to the set of complex numbers.
इस एपिसोड विच तुसी प्रॉपर्टीज ऑफ एडिशन एंड सबट्रैक्शन ऑफ कंपलैक्स नंबर्स बारे पढ़िया है। मैं उम्मीद करदी हाँ कि तुहानू एपिसोड पूरी तरह समझ आ गया होवेगा। धन्यवाद।